Hello, today we are going to talk about graphs. Now, as our first scenario is this, what is the most important characteristic when selecting the President of the United States, which we've seen last time when talking about summary tables. And we see in the results here, we have the summary table. Now, to create a graph, you first need the summary table. And the question might be asked, well, why even create a graph if I have to create the summary table first? And the reason for that is the old saying, a picture is worth 1,000 words. It's nice to be able to communicate with graphs because it's usually easy to communicate and you can get the message across fairly clearly with a graph. Now, for this scenario, we need to recall one thing in particular. The variable is what is the most important characteristic when selecting the President of the United States. And the level of measurement in this case is categorical. And so we're going to talk about the different types of graphs when you have categorical level of measurement. And the first type of graph is what's called a bar graph, or sometimes it's called a bar chart. And the way the bar graph works is it has a vertical axis and a horizontal axis. And on the horizontal axis, we put the outcomes from the variable: promise, moral, and decision. Now, why did I put those in that order? Well, I put them in that order because that's the order of the table. Could I have done moral first and then decision and promise last? Yes. And why is that the case? It's because it's a categorical variable. There's no ordering to the outcomes, so I can put them in any order that I want. Now, on the vertical axis, we can put any one of the three summary statistics that we want. And so I'm going to do a frequency first. And so when I look at the actual frequencies here, I know I'm not going to get above 14. So we come up here and we go 15. And we try to break this up into thirds approximately. This is going to be 5 and this is going to be 10. And so promise has a frequency of 6. So we're just above 5 and we create a bar at promise. And then moral is at 5, so we go to 5 and create a bar. And decision is at 14, which is just below 15, and we create a bar. And so this is an example of a frequency bar graph for our scenario here. And so some things we can notice very easily is it's real easy to see a decision was selected most often in the sample because it has the highest bar. Promise and moral are very similar to one another. Another thing to notice about a bar graph is this space between the bars. The bars do not touch. And so the reason for that is because we are dealing with a categorical level of measurement. There is no ordering to the outcomes, and I can place them in any order. So that's why we don't allow the bars to touch. Now, if I wanted to do a relative frequency or a percent, all I have to do is change this summary, but the heights of the bars relative to one another are going to stay the same. And so if I want to get rid of all of this and go, okay, well, let's do a percentage bar graph. This was just below this, so if we call this 60% and 40% and 20%, and these are percentages, that 56% is just below the 60. Moral is at 20% and 24% is just above the 20%. And so whether you want to do a frequency, relative frequency, or a percent bar graph, you put the appropriate summary statistic on the vertical axis and the outcomes on the horizontal axis. And again, the bars do not touch in a bar graph. It's because we're dealing with categorical level of measurement and there is no ordering. Another type of graph with a categorical level of measurement is what's called a pie graph or a pie chart. And a pie, other than the delicious stuff to eat, makes up this circle. Look at that perfect circle. Now a pie graph, because we're really dealing with with the notions of a whole here, we can really only do this with a relative frequency or with a percent, because you have the whole being 1 or the whole being 100%. But how they look between a relative frequency or percent is basically the same. Now what I like to do is I like to start with a vertical line here, and then if we come to promise, and that's 24% or 0.24, that is just about a quarter. So if I come across perfectly horizontal, it'll be a quarter. So I'm going to come up just a little bit and call that promise. And if I come straight down, that would be a half, which wouldn't be quite right. So we're going to go a little bit less. And that's moral, and the rest of this is decision. And that's how you create a pie. Now, in chapter 6 of the book, it talks about how to get the exact angles using the relative frequencies. But for our purposes, we just need to get it close. A couple of things to note is sometimes the labels are put within the slices of the pie. Sometimes things are done like this, where you got a P, and then you might have a 0.24 on the outside, an M, 0.20, and then a D and the 0.56. Or probably what's most common is the 24%, the 20%, and the 56% are put there. And so they're given labels on the slices of the pie and then the percentages there. So the two main types of graphs for categorical level of measurement are the bar graph and the pie chart. The third type is what's called a pictogram. And what a pictogram is it's very similar to this bar graph, but instead of putting bars here, go pictogram. Instead of putting bars here, we put some sort of a picture. And so we do promise at 24%. You go, okay, well, I'm going to do a picture, but we're going to call that, here's the American flag or something like that. Or it could be a picture of the president's head or some other kind of thing for the picture. One of the problems, though, with a pictogram is, well, if this American flag looks scaled, do you do a tall, oops, a little too far. Do I do a tall, skinny flag, or do I scale the flag appropriately? And that's one of the misleading things about a pictogram is sometimes they're long and skinny like this, or sometimes they become wider in terms of scaling it. If you look at chapter 6 in the book, it gives some better examples of this. Now, what we see most often is a bar graph is used most often in the scientific literature, and pie graphs, pictograms are a little bit more used often in the news outlets. And so this is how it works for graphing with categorical level of measurement.